Hi everyone, today we are doing the principal component analysis. So what is a principal component analysis? So basically principal component analysis is one of the technique that in the Python. So whenever we are applying the machine learning model, so before the machine learning model we are using the PCA. So PCA is, let's suppose I have the one data set. In this data set I have around 32 features. You can see here, this is the columns. 32 features I have. I want to reduce this feature into the main features, and that will be help me to increase the accuracy of the model. So I already applied the machine learning model on this data set, and if you can see here, so I have one target variable is that is cancel, and I have the decision tree machine learning model and the accuracy is around 81%. Then I applied two more model here, the k nearest, and the another is a logistic regression, but the accuracy is very low. So how I can increase the accuracy of this machine learning model? So I'm using here this PCA component, principal analysis component, that will be reduce the large data set into the to the if you want the two components or three components, so you can do it. So because if the many variables will be there, so the noise is more increased and your model will be not accurate, correct. So for this we are using the principal component analysis for this. So first of all, I'm importing my library. So my library is sklearn in decomposition, that import PCA. Then after that, we need to select the R features of the numerical features. So I'm declaring here num equal to the my dataset name is hotel underscore df. So this is my dataset name. So I'm taking here then dot select. So what I need to select? I need to select the data type. So that is a data types, and here I'm including the which features. So which data type? So that data type is float, and float 64. I will take here in the single quote float 64, and one more I'm taking here the integer. So same in the single quote you have to declare. So I want this data type here. Then this is the my main features, okay, numerical features. Then I'm doing the standardized the data. So what is the standard scale I'm using here for this? So standard scale is basically used for reduce the gap between the features. So I'm using here the scalar equal to standard scalar. So standard scalar will be convert your that will be reduce the variance between your features, because right now I have the too much variance between the features. So that will be used whenever we are applying the machine learning any model. So here this is my feature is numerical feature standard equal to scalar dot fit transform. So what I used here, scalar dot fit transform method. So this is my method, and which features my numeric features. So I'm putting here the num. So this is my features. Now I'm simply apply here the PCA. So PCA is equal to, and I'm calling the PCA technique here PCA, then open bracket open close, then PCA result. So what is a PCA result? So I'm declaring one variable here, that PCA result equal to my PCA dot fit transform. So we are calling here the fit transform feature. Then my standardized data. So this is my standardized data. So I'm taking these numerical features of the standard scalar. So I'm pasting here, and this is my PCA result. So PCA is done. So this is only the PCA. We need to do it. Then after that, I'm creating here the one of the graph for the PCA, so that you can understand what is the PCA and the how the number of principal components, what is a cumulative explained variance, what is a variance between the two components. So that will be understand with the graph. So I'm plotting here the one graph. So using the matplotlib, So I'm putting here the my range. So what I'm taking my range from 1 to so I'm taking the length of that particular feature. So length function, then PCA dot which one, the explained variance ratio. So this is the one of the feature of the PCA that will be give us the variance ratio. So after this plus one, and so this is kind of loop, so that will be go. Then after that, the here we need to put a comma. Then PC explain the variance ratio again. So here I'm putting the PCA dot variance, sorry, explained variance. Then I'm marking the with the marker. I'm using the marker here. In the marker, I'm putting here the this single O. Okay, so this is the plot we are creating here. Okay, so you can see here the simple plot is here and it's showing the uh, features from the number of components of principal components. So I'm also making one X label and the Y label so you can easily understand what we are doing here and which feature is this. So in the X label, so what is X label? The number of principal components. This is the X. And what is a Y? So Y is the cumulative explained variance. Okay, so this is the component. Okay, so this is and X and Y. So now you can easily understand what is your number of principal components and what are the cumulative experience. So now after this, how many components you want? So let's suppose I want the number of components 2 only. So I'm putting here the n components and based on our data set. Okay, so we can adjust it. So I'm putting only the 2 in the number of components. Then I'm simply apply the PCA with the choose number of components. So we need to write here on the PCA equal to PCA. Then how many components? The component variable will be here, the n underscore components. Then equal to n underscore components. So that is the our variable name. Okay, so that I mentioned here. Then how the result will be worked. So then this is the result that will be PC underscore components. Then I'm saving this PC result will be here in this one. So PC result equal to PCA dot fit transform. So I'm transforming this my data into the numerical features of the standards. So that already we converted. So I'm putting here numerical feature standardized. So standardized. So that I put it here. Then now the PC result is raising. So this is the explained here. Now the PC result is there. Then we have to create the PC data frame. So because that data frame will be help us for the machine learning model. So that is an important one. So PCA underscore df, I'm creating one data frame. So for creating a data frame, we are calling the pandas. So in the pandas, we are using the data frame. Then what is my data? Data equal to my PCA result. So that PCA result we need to convert into the uh, this one in the data frame. Then which columns are there? So I'm saying that I have some columns. Which columns? So for this I'm using here the in the array I'm putting the F. So let's suppose I have 2 features, 3 features, so that I can mention it. So I'm writing the PC then let's suppose PCA1, PCA2, PCA3, like this we have. So I'm creating the one loop here. So this will become in the curly brackets. Then for I in range, so this is the I in range, and how many components is there? Let's suppose you put it the two components, three components. So for this we are creating the loop here, 1 comma n underscore components plus 1. So this is the my data frame. So we created a one data frame here. Now what we will do, we will are concatenate the PC result with the original data. So how we can do it? So I'm creating new variable here, result underscore data equal to pd dot data frame. So this is my data frame I created here. Then I'm writing the data equal to PCA underscore result, that variable we created. Then columns, how many columns we have? So we have only two columns there. So columns equal to so PCA1, PCA2. So PCA1 comma PCA2. So this is two components are there, so that I mentioned it. Now the result is available in the result dataset. Now we need to check what is a let's see the what is the data there. So I'm simply writing here the result. I need to see what is the data inside. So result data dot head. So my data is PCA1 and PCA2. So this is my data set PCA1 and PCA2. Okay. So let's create the one graph. So with the one graph, we can understand how this will be work. So I'm creating the one graph, and that will be show how the PCA will be using. We are using for dimensionality reduction. So I'm creating here the fixed size. I'm creating the figure here and declaring it. This is a frame for the plot. Then I'm creating here the this scatter plot. So scatter plot will be give us a clear picture of this data. So result underscore data. Then I have to mention the that PCA1 and PCA2. So this is the two data set I have, result under PCA2. So this is two data set we have, and what we want the my target variable. So what is the target variable? Let's suppose I have the target variable here, that my first data set is I have booking data dummies. So this is my data set. In the data set I'm taking the target variable as a is cancelled. So I'm using here is underscore cancelled. This is my data target variable. Okay, and the my x variable will be x label will be PCA1, my second variable will be PCA2. So that PCA1 PC1, then y variable will be PC2. So y PCA2. So this is the two variables, and what is this? This is basically showing the target value with the my target variable is cancelled, and two data set will be there, that PC1 and PC2. Now you can see here this very beautiful graph. In this graph you can see here this showing the what is the difference in the one of the two classes, what is a variance. Okay, so that variance is very important when we creating this PCA. Okay, so now my model is converted into two components. Okay, now I can easily apply the machine learning model. So before that machine learning model, I will show the accuracy of the model if I'm using the KNN. Now, again, I'm using the KNN here. So first of all, I'm showing the accuracy of the KNN here. So now you can see here the before I applied the KNN here, and the accuracy is coming around the 78%. So now again I'm applying the KNN here. So I'm simply copying this data and pasting the down. And so first of all, I need this data. So before this, I need to split my data set. So how I will be split? So I have the two data set here. First of all, this data set in the X and Y. In the X, I'm taking the PCA, that is my independent variable. So I'm taking here the PCA underscore data frame. So that we data frame we created, and the values of that data set, that PCA data frame and the values. And the second, I'm taking the my second data set. So my second data set is basically the hotel underscore df, that is my original data set here. So I'm writing here a hotel underscore df. Then I'm simply writing my data set, that target column name here. So this is my target column name. And now I'm splitting my data into the X and Y. So this is 20% size I'm taking in testing, and the random state is 42. So I declared my X and Y. Now simply I'm applying the machine learning model here. So I'm using the KNN. So for KNN, simply using this one, then I will see what is the accuracy will be coming here. So right now it's a 78%. Let's see after this how much accuracy is increasing in our model. So I applied the another machine learning model. Now you can see here the machine learning model has the KNN has the accuracy around 87. Before is showing the 78% before PCA. So that's the reason we are using the PCA for the in the machine learning, so that will be help us to increase the accuracy of the model. So this is all about the PCA. Thank you.